So now let's talk about lumber. So wood is that the fibrous substance which composes the trunk and the branches of the tree that lies between the pith and the bark. So the versatility of using wood in every construction has lifted it to its present importance and high demand in almost all types of construction. So even with the introduction of new materials and new methods of construction, wood is evidently much in use. Wood, because of its strength, light in weight, durability, and ease of fastening, become one of the most important building materials. So that in all construction and on all types of construction, wood is applicable to use. So now, definition of terms. What is lumber? So lumber is the term applied to wood after it has been sawed or sliced into boards, planks, timber, or etc. So rough lumber is term applied to undressed lumber. In short, with lumbers which have rough surfaces. So S2S and S4S are dressed lumber, wherein the number connotes the smooth side. So for example, S2S, it has having two smooth sides, and S4S having a four smooth sides. So slab is a kind of rough lumber cut tangent to the annual rings running through the full length of log containing at least one flat surface. So surface or dressed lumber is a planed lumber having at least one smooth side. So next is timber. So it is a piece of lumber 5 inches or larger in its smallest dimension. So plank is a wide piece of lumber from 4 to 5 inches thick. So board is a piece of lumber less than 4 centimeters thick with at least 10 centimeters wide. So flitch is a thick piece of lumber, and fine grain when is the lumber which is when the annual rings are small. The grain or marking which separates the adjacent ring is said to be fine grain. When large, it is called coarse grain. So next is the straight grain, which is term used when the direction of the fibers are nearly parallel with the side of edges of the board. So crook or cross grain is a lumber taken from a crook tree. So now, in classifying woods to use from building construction are those which are grows larger by addition of layer on the outer surface each year, known to be botanist or exogen. So wood is classified according to first mode of growth. So mode of growth, there are two types. So first is indigenous. Indigenous are those trees that grows from the inside. Those kind of trees is applicable for or preferable to lumbering. So next is exogenous. What are those trees that outward growing trees, and it is preferable for lumbering. Next is with respect to density. It's either soft or hard. So next is according to its texture appearance. So it has plain, grain, or figured or marked. So these are the types of wood or the patterns of the wood. So we can see the heart shake, the broken branch, the star shake, the wind shake or cup shake, and it also has radial, quarter tangential or plain or bastard sewing. So next is the method of log sewing. So lumbering is the term applied to the operation performed in the process of operation performed in preparing the wood for commercial purposes. Logging is the process of operation from cutting trees, hauling and delivery to the sawmill or sewing. Sewing, on the other hand, is the operation of cutting logs into commercial sizes of lumber. So next is the methods and manner of log sewing. So first is the plain or bastard sawing. Next is the quarter or reef sawing, which compasses the radial, tangential, quarter tangential, and combined radial and tangential. So next is the defects in woods. So the term defects refers to the irregularity found in wood. So first is causes by abnormal growth such as heart shakes. So heart shakes are radical cracks in wood originating from the heart of the logs. Heart shake is commonly found in old trees. So next is a wind shake or cap shakes, are cracks or breaks across the annual rings of the wood during its growth caused by excessive bending of the trees due to strong wind. Next is star shakes, are composed of several heart shakes radiating from the center of the log in a star-like manner, and knots occurs when the starting point of a limb or branch of the tree. So next is due to deterioration. So first is the dry rot is caused by fungi in a seasoned lumber due to the presence of moisture. So next is wet rot, takes place sometime in growth or the tree caused by water saturation. So next is seasoning of lumber. So by nature, trees contains moisture, so it can be seasoned by this moisture that contained in a lumber must be expelled thoroughly to preserve the wood from shrinkage or decay. So in experiments prove that wood immersed in water immediately after cutting is less subjected to splitting and decay. It reduces wrapping but becomes brittle and less elastic. The soaking of wood in liquid is the oldest method of seasoning lumber, introduced and practiced by ancient Roman builders. So now we all know we can classify two methods of seasoning lumber. First is the natural sunlight or air seasoning process. Is considered as one of the best methods used in seasoning of wood, although the period involved is relatively longer. So next is the artificial seasoning. Is a process where lumbers are stuck in a drying kiln and then exposed to steams and hot air. Under this method, lumber undergoes a quick drying process. So next is the artificial method of seasoning are by forced air drying and by kiln drying and by radio frequency dielectric drying. So wood must be in good seasoning is the primary consideration of successful preservation of food. Wood does not decay naturally through age, nor will it decay if it is kept constantly dry or continuously submerged in water. So the common causes of decay in wood are alternate moisture and dryness, fungi or molds, insects and worms, and heat and confined air. So the process of preserving wood are external process. The wood is coated with a preservative applied in a paint or to penetrate the fibers of the wood. And next is the internal process. A chemical compound is impregnated at a prescribed pressure or permeate the wood thoroughly.
Unit of measure in lumber. Board foot. Board foot is the unit of measure used in computing the volume of lumber. One board foot means 1 square foot by 1 inch thick lumber, or an equivalent of 144 cubic inches. The width and thickness of commercial lumber are expressed in inches, while the length is in feet. Board foot can be found by dividing the product of the thickness, the width, and the length by 12. Here is an example of a board foot problem. Find the total board feet of 5 pieces 2 inch by 6 inch by 14 feet lumber. Solution. The formula for board foot is equal to n, which is the number of pieces, times t, the thickness, w for the width, and l for the 5 multiplied to 2 by 6 by 14 over 12. These values are already given, so we only have to substitute them. The answer would be 70 board feet. Board foot for round log. Finding the net board foot of a round log or a standing tree with its known diameter and height can be answered using the following formula. The board foot volume for a round log is the quantity d minus 4 squared times L all over 16, where d is the smaller diameter of the log, L is the length of the log, and 4 is the constant reduction factor. Here is a sample problem for the round log board foot. Determine the total board foot lumber which could be derived from a round log 28 inches diameter by 6 meters or 20 feet as shown below. The solution goes like this. The formula for board foot is equal to d minus 4 squared times L all over 16. Substitute the given values 28 minus 4 squared times 20 feet over 16. The answer would be 720 board feet. We need to remember that the thickness and width are always in inches, while the length should be in feet. For the manner of payment and sewing or slicing lumber. So there are two methods of computing payment for slicing or sewing lumber. These are the by board foot and the meter length. In by board foot, you need to compute the total board foot of sewed lumber, then multiplied by the agreed price per board foot. Meter length, on the other hand, is multiplying the width in inches by the length in meter times the agreed unit price per meter run. Manner of payment sample problem. How much will it cost to slice a 6 inches by 6 inches by 3 meters wood to produce a 2 by 6 lumber if the unit price is 2 pesos per board feet? Here is the figure for the problem. Solution. For a board feet method, you need to find the total board foot of lumber. 6 inches by 6 inches by 10 feet also is equal to 30 board feet. Next, multiply by the unit price of 2 pesos. 30 pesos times 30 pieces times 2 pesos is equal to 60 pesos. Now for the by inch meter method. You need to multiply the width by the length of the lumber. Say the width is 6 inches multiplied to the length of 3 meters is equal to 18 inch meter. Now multiply by the number of cuts. The number of cuts is 2. So 18 multiplied by 2 will be 36 inch meter. Now, multiply by the unit cost. The unit cost will be 1.65 multiplied to the number of inch meter which is 36. Now you have the following value of 59.40 pesos. For the wood post, in estimating the wooden post for building structure, there are only 3 things to consider. So the size of the post, number 1. Number 2 is the quantity of number of posts. And the third one is the length or height of the post. The size of the post is already indicated in the plan. So as you can see in the figure, the girts, the floor joist, the girder, the post, the floor line, and the ground line are already indicated together with its following dimensions. The quantity is directly counted in the plan and the length is determined through the following considerations. First one, for one-story building, verify if the elevation height indicates from floor to ceiling. So if the ceiling is below the girth, add the depth of the girth, including the bottom chord or the rafters, to the height of the post. The second condition is, for a two-story building, verify if the height indicates from floor to floor. If so, then consider the additional depth of the girder, the floor joist, and the flooring. For the second floor, add the depth of the girth, bottom cord or rafters to the height of the post. The final condition is take note that the commercial length of lumber is always of even number. So if the computed length is odd number, then you need to adjust the order to the next even number length. Here is an example problem for the wood post. From the figure below, determine the length and board foot of the post required if there are 8 pieces of 6 inches by 6 inches wood post. So here is the solution. First, you need to find the total height of the post from floor to ceiling. The total height would be 2.70 meters as indicated in the plan, plus 2.70 meters is equal to 5.40 meters. Next, determine the depth of the girders, the floor joist, flooring, and the girth. The total depth of the following is 0.575 meters. Next, add results of the total height and depth to get the total length. The total length would then be 5.975 meters. In order to convert this into feet, you need to divide the 5.975 meters into 30, which will then become 20 feet. Now, for the board feet, you need to multiply the number of pieces times the thickness times the width times the length of the lumber over 12. The number of pieces would be 8, multiplied to the 6 inches by 6 inches by 20 feet length, all over 12. You need to order the following board feet of 480. Now for the girder. Girder is a structural member of a building that carries floor joists and the flooring. It is determined by direct counting method based on the framing plan of the building. The length, however, is subjected to the following conditions. The girder length condition 1. If the span or distance of the post is indicated from center to center, the length of the girder is equal to the span plus one side width of the post. This figure is the center to center span. For the second condition, if the span of the post indicates from outer to outer side of the post, the girder length is equal to the span of the post. As you can see in the figure, the span of post is equal to its length. This is called the outer span. For the third condition, if the span of the post indicates from center to outer side of the post, the girder length is equal to the span plus 1/2 the width of the post. You can see that the length is equal to span plus 1/2 side of the post. This is called the center to outer span. Now for conditions 4 and 5. If the span or distance of the post indicates inside measurement, the length of the girder is equal to the span plus 2 width of the post. On the other hand, if the second floor has an overhang wherein the girder has to carry the floor joist, the girder length is equal to the span plus the overhang. Now for the floor joist and the wood flooring. The floor joist is a structural member of the building that supports the wood flooring. So floor joist this is estimated by the direct counting method based on the floor framing plan. However, in the absence of a detailed plan, estimating could also be done if the spacing and the length of the girder is known. For floor joist and TG flooring. TG means the tongue and groove respectively. Floor joist and TG flooring. PG is a popular name for tongue and groove wood board used for flooring, ceiling, paneling, and forms. Its thickness of the board varies from 16 to 20 mm, and its width also varies from 7.5 to 15 centimeters. There are two methods presented in how to determine the required number of pieces in the board foot of PNG for a known floor area. One is the direct counting method, and the other is the board foot per square meter. Here is a sample problem. From the floor framing plan as shown below, determine the number and board foot of the floor joist and the PNG flooring required. So here is the figure with 10 meter length and 3.5 height. The solution for the floor joist: you need to determine the length of the girder divided by the spacing of the floor joist, which are given in the problem. So 5 meters over 0.30 is equal to 16.6. This number represents the spacing of the joist. You need to add 1 to get the exact number of floor joist. So it will become 17.6, or say 18 pieces. Now for the 2 span, you need to since it has 2 spans, you need to multiply this 18 to 2. This will become 36 pieces. Determine the length of the floor joist in feet. 3.5 over 0.30 is 11.6. So let's say 12 pieces. So now you need to order 36 pieces of 2 inch by 6 inch by 12 feet, which is the floor joist in feet, which will then be equal to 432 board feet. So for the PNG flooring, here is the solution. You can use the direct method. You need to find the length of the floor joist, which is 3.5 meters. And then using 4-inch PNG, divide by the effective width. 3.5 over 0.0875 is equal to 40 pieces, multiplied to 2 span, which is then will be equal to 80 pieces. The length of the girder is 5 meters or 18 feet. Now, you should consider ordering 80 pieces of 1 by 4 by 18 feet or 480 board feet for the PNG flooring. For the siding wood board, the common types of commercial siding wood boards are the single stone cut, the double stone cut, the DCB, the V-cut, and the weather cut. So what is a siding wood board? So the thickness of the siding wood board varies from 16 to 20 millimeters. Likewise, the width ranges from 15 mm, 6 inches to 20 mm or 8 inches of even length from 8 to 16 feet. The quantity is estimated under the following considerations. 1. That the area of the opening, such as windows, doors, and the likes, are subtracted from the gross area of the wall to be covered by the siding wood boards. Second, you need to consider the additional depth length of the girth, flooring, floor joist, and the girder. The second is the length of the siding wood board must be specified to avoid joints in between the heights. Here is a sample problem for the siding wood. In the following figure below, find the number of 8 inches double stone cut siding wood board. Refer to the table for the quantity of siding wood board. So in table 4.2, you can see the quantity of siding wood board, which with the size of the wood board is in inches and centimeters, and the number per meter run, and the approximate board feet per square meter. So the solution goes like this. Determine the length of the wall board. So the length would be adding the floor to ceiling, depth of girth, flooring and joist, depth of girder, which will then be equal to 3.9 meters or 13 feet. So you need to order the length of 14 feet. Always add its length. Length of the wall will then, the length of the wall is 5 meters. So you need to subtract 2, which is the length of the window, and it will then be equal to 3 meters. Now you need to refer to the table for an 8-inch or 20 centimeter wood board. You can multiply the 3 meter times 5.33, which will then equal to 16 pieces. Thus, you need to order 16 pieces of 1 inch by 8 inch by 14 feet over 12 or 149.3 board feet.
Good day, I'm Rizal May Divina Gracia, and I'm going to continue the topic about lumber. I will tackle 5 subtopics. So first, let's go to stud. Stud is by definition the structural member in building construction wherein the sidings or partition boards are fastened. And it's sometimes referred to as the ribs of wooden walls or partitions. So there are 2 methods on how to find the quantity of studs at a given vertical and horizontal spacing. It is by direct counting method and by the square meter method. So later I will show you on how to use those methods. Here you can see a table of which shows the lumber size in inches and spacing in centimeters and its corresponding multipliers. So later also we will use this in quantifying the stud. So for the sample problem, a wall partition 5.80 meters long and 3.40 meters high. Specify the used 2 inches and 3 inches studs spaced at 60 centimeters on center both ways. Find the total board foot required. So solution, by direct counting first, find the number of vertical studs. You'll just have to divide the measurement perpendicular to the vertical studs over the spacing. So 5.80 over 0.60 is equals to 10, which is rounded. This is the number of spacing. So add 1, the number of spacing we got, you just have to add 1 to get the number of studs. So it's equals to 11 at 3.40 meters or 12 feet. Second, we must find the number of horizontal studs. So just have to divide the measurement perpendicular to the horizontal studs over the spacing, and add 1. So 3.40 over 0.60 plus 1 is equals to 7 at 5.80 meters or 20 feet. So to this problem, I must order for vertical studs 11 2 inches by 3 inches times 12 feet. So to get the board feet, just have to multiply the 2 times 3 times 13, which are the measurement of the wood, over 12 to get the board feet. So 2 times 3 times 12 is over 12 is equals to 6 times 11. So it is equals to 66. So for horizontal studs, it's the same process. 2 times 3 times 20 over 12 we'll get 10 times 7, which is the quantity of horizontal studs that we calculated. So adding the 2, the vertical and the horizontal studs, we could get the total of 136 board feet. So by area method, it's a simple method. You just have to find the area of whole partition, which is length times width, 5.80 times 3.40, and we'll get 19.72 square meters. And then refer to table 4-2, look for 2 inches by 3 inches at 0.60 times 0.60 meters spacing. So looking at the table, we will get a multiplier of 6.898. So we just have to multiply it to the area that we got. So 19.72 times 6.898 is equal to 136 board feet of 2 inches by 3 inches lumber. So the next, for ceiling joist, by definition, ceiling joist is a structural member in building construction where the ceiling board is fastened, otherwise known as the nailing strip. So the common size used for ceiling joists are 1x2, 1.5x2, 2x2, and 2x3 lumber spaced. So for sample problem, find the total board foot required for a 4x5.80 meters living room using 2 inches by 2 inches ceiling joist. Space at 40 by 40 centimeters on center. Solution by direct counting. Find the number of joists perpendicular to 5.80 meters. Then add 1 to get the exact number of joists. Then find the number of joists perpendicular to 4 meters span, which is the horizontal. We have to find. Then we will get the total board feet of 147.99 board feet. And if 20 feet is not available, a 10 feet lumber would be alternative. By area method, first find the area of the ceiling, then refer to table 4-3, yielding also a 147.99 value, which is the same with the direct counting method. Next is ceiling board. There are numerous kinds of ceiling board of different brand, quality, and dimensions available for building construction. However, the simplest way of finding the number of boards required is to divide the total ceiling area by the effective covering of one ceiling board chosen or by the square meter method with the aid of table 4-3. So, a sample problem. A bedroom with the general dimensions of 4 by 5 meters specify the use of 1/4 inch by 4 inch times 8 inches plywood ceiling on a 2 inches by 2 inches ceiling joist based at 40 by 60 centimeters. Find the number of plywood and the ceiling joist required if there are 5 rooms of the same size. The solution is get the coverage method, the ceiling joist and the ceiling board. First, find the area of the ceiling, then see table 4-3 and multiply it by 5 because it has 5 rooms, yielding 537.3 board feet of 2 inches by 2 inches. For ceiling board, same, find the area of ceiling and refer to table 4-4. Refer to table 4-4 for the dividend, and for 5 rooms, order 35, order 1/4 by 4 by 8 plywood. Now let's go to the door frame. Estimating the material for fabrication of door frame is simply determining the size and length of lumber that will accommodate the door panel, whose width varies from 60 to 100 centimeters wide. So here is a sample problem. A 20 classroom building with 2 doors, each specify 3 by 6 door jamb. List down the materials needed for fabrication. Yielding 14.5 feet. Next, determining the length of the header, yielding 3.5 feet. The total length would be 18 feet. So to order, must be 40 pieces, 3 inches by 6 inches by 18 feet, which is equals to 1080 board feet. That's for ordering one length of the jamb. In ordering combination of jambs and headers, one header is 3 feet to 6 inches or 3.5 feet. The total length of 4 headers is 14 feet. So for 40 headers, order 10 pieces, 3 by 6 by 14. And for jambs, 7.3 plus 3 inches times 2 because there's two sides. Order a 14 to 6 inches or 16 feet. So the lumber length is of even numbers for 40 jambs order. Order 40 pieces 3 by 6 by 16, which is 960 board feet, and 10 pieces of 3 by 6 by 14, which is 210 board feet. So the total would be 1170 board feet. Lastly, for window frame, the different parts of window frame to be considered in estimating are the jamb, seal, header, transom, and mullions. So for sample problem, a low-cost housing project requires 50 pieces window frame as shown in figure 4-22. List down the materials needed for fabrication. So for solution, for jamb, first you must determine the total length and multiply it by 2, which is 320 centimeters or 12 feet. So for jamb, you must order 50 pieces of 2 by 6 by 12. And to determine its board feet, you must divide it by 12, yielding 600 board feet. For header and seal, same. Calculate the total length, 220 plus 10, and multiply it by 2. The quantity of its sides, which is equals to 460 or 16 feet. So, order 50 pieces of 2 by 6 by 16, and to know its board feet, just divide it by 12, yielding 800 board feet for header and seal. For mullion, order 100 of 2 by 4 by 1.50 meters or 50 pieces of 2 by 4 by 3 meters. For transom, 100 of 2 by 6 by the total length, 2.20 plus 10, and to know its board feet, divide it by 12, yielding 800 board feet.